So if you compare the pointer assignment statements in line number 24 and line number 26, they are not very different. So there is one difference in these two pointer assignments. That is, in line number 24, we are trying to take the address of a prefix incremented value. And in line number 26, we are trying to take the address of a postfix incremented value. But the compiler is complaining for this particular type of a pointer assignment. And why is this so? So if you're curious to know about this, then watch till the end of the video. So in order to understand why taking the address of a postfix increment is a problem, we need to understand the concept of an L value and an R value. So up until C++ 98, the definition of L value and an R value was quite simple. So L value is anything to the left of an assignment operator and R value is anything to the right of an assignment operator. So in this example, we have var to be var is an L value and 10 is a R value. But with C++11, the definition of L value and R value changes. So with L value is anything that you can take an address of. Now taking this assignment as an example. So I said that L value is anything that you can take an address of. So we can take an address of var, right? So var is an L value, but we can't take the address of 10. So 10 is an R value here, right? So it's the compiler is giving a problem here. Now I know that it is quite obvious for most of the C or C++ programmers as to why this is a problem, but let's try to go a bit deeper. So 10 here is a temporary value. Now what I mean by a temporary value is temporary values do not exist in stack or heap or anywhere in the memory. If you take this particular assignment as an example, this var variable exists even after line 33 gets executed because var is a stack, it's on the stack. But 10 does not exist in the stack. It's a temporary value and it ceases to exist after this particular line gets executed. So one extension for an R values are basically temporary values. So there are two definitions. R values are anything that you cannot take an address of, and R values are basically temporary values. Now let's try to extend the concept of L value and R value to a better example. So basically I have a class here called person and I have a utility method getPerson which basically returns the object of the person, object of the class person. And now let's look at this code here. So I'm invoking getPerson method which returns me the object and I'm assigning it to a variable p, and I have pointer assignments here, taking the address of p and storing the address of p in a pointer called p1. And in this particular pointer assignment, I'm trying to take the address of the returned value of getPerson and then storing it in p2. Now let's see what is happening in line number 43 and line number 45. So line number 43 is correct, right? Because we are trying to take an address of an L value here. And in line number 45, it's an issue. Now let's see what is the exact issue. Okay, so the program compiled and it's complaining at line number 45, there's an error of taking address of an R value. So it's complaining that it cannot take the address of this getPerson, the returned value of getPerson. So it's basically complaining that the value that is returned by getPerson is an R value. Now what is happening in getPerson? So getPerson is basically returning an object of a person, but it's a temporary object. Now what do we mean by a temporary object? Very similar to a temporary value. Temporary object is something that does not exist on stack or heap or anywhere in the memory. It just the life of that temporary object is only till that line of execution is done. So in this particular example, line number 41, get person, the object that is returned by get person ceases to exist just after the line number 41 is executed, right? So that is exactly what do we mean by temporary object. So R value, we can take the extension of an R value as R value are not just temporary values, but they're also temporary objects. Now that we have a good understanding of L value and R values, let's look at our original example of the two pointer assignments wherein we were trying to take the address of prefix operator and the address of the postfix increment operator. Let's try to compile this and see if what is the issue. Yeah, so it's complained at line number 50, L value required as unary operand operator. So it says that can take the address of only of an L value, and which basically means that var plus plus is an R value here. Now to understand what the difference between line number 47 and line number 50 is, here in line number 47 we are trying to take the address of an L value here. Now what happens with the prefix increment operator here is var, this basically literally translates to var equal to var plus 1, right? And ultimately we are taking the address of a L value here, that is basically something that is existing already on the memory. But in the line number 51, var plus plus, the way this var plus plus operates is, first it creates a temporary object. First it creates a temporary value of var plus 1. Then we are trying to take the address of the temporary value. And that is why we are seeing this error here. So that is the exact difference between these two pointer assignments and why we are seeing this original issue. So why is this R value so important? R value and R value references forms the basis of move semantics. Now, move semantics is nothing but using std move, and std move is used for efficiently transferring objects between function calls. And std move is being used in almost all modern C++ projects. One example that I have here is the Chromium code, wherein in the logging module, I see that std_move is being used to pass the parameters that are being captured to another method, a method that basically emits events. So yeah, in the next video, I'll try to explain std_move. And yeah, thank you for watching.